Okay, 2.3. I should mention for 2.2 I kind of stopped the video there, but you would also have to check to be sure. You would need to check that the optimal abatement by the monopolist firm was actually within the bounds of reasonableness. So it could be that the monopolist would actually, the way we've done it, they would want to have emit more than they would emit in laissez-faire, to then sell even fewer permits and make more profits. But of course, in practice, they would never emit more than laissez-faire. They would emit zero. You can't they would emit the laissez-faire quantity and then just hoard permits. So you could have solutions like that going on. So you would need to watch out for that if you were actually dealing with a real problem. You could end up with a monopolist just hoarding permits and not using them to drive the price up for the other firms and raise its profits. Okay, finally then, 2.3, and again we've got, or this time we've got two firms trading permits. And again they've got baseline emissions of 10, and again they've got cost functions for abatement that are slightly different. And the regulator gives 4 permits to each of the firms, but for some reason firm 1 has some kind of advantage over firm 2. And so instead of some kind of perfect market transaction, firm 1 is going to present a take it or leave it offer to firm 2 at a certain price. It's going to say, buy any number of permits you choose to at this price. Firm 2 can either accept and buy permits at that price or not. What happens? Okay, so we need some notation. Typically, we're going to just assume that a trade happens at some price. P, that the price P is offered and the trade happens. And then we find the optimal P from firm 1's perspective, and then we check whether the trade is actually going to happen compared to the corner solutions with no trade. Okay. So, firm 1 makes an offer to buy permits. No. Okay. Firm 1 makes an offer to buy permits at price P. Why do we assume that firm 1 is going to buy permits? Well, they have higher abatement costs, don't they? 2A1 squared instead of A1 squared. So on the margin, their abatement costs are higher. They're likely to be wanting to buy permits. So firm 1 makes a take it or leave it offer to buy permits at a price P. And firm 2 sells Z permits at that price. So firm 2's emissions must be 4, which is its initial allocation for permits, minus Z. And firm 2's baseline emissions are 10, and its abatement is A2. So we've got 4 minus Z is 10 minus A2. And for firm 1, we've got that 4 plus Z is 10 minus A1, isn't it? We're going to use that later. Okay, but for now we're interested in firm 2. So, firm 2's problem is to maximize its profits. And what are its profits? They are the permit price times the number of permits that it sells. Which is Z. No. Yeah. Firm 2 is selling permits, so it's P times A2 minus 6, isn't it? No, sorry. Yeah. Okay, sorry to stop there, but there's something wrong with my crib sheet. This is the problem, isn't it? Maximize pi 2, which is P times Z, the number of permits that firm 2 sells, and Z, taking that over, and this stuff over here is A2 minus 6. So that's the revenue from selling permits, but then we've got the costs of abatement, which are minus 9 plus A2 squared. So the firm is choosing A2 to maximize that. So if we take the first order condition, we get that P minus 2A2 equals 0, P equals 2A2. A2 is P over 2. So, if firm 1 sets the price of P and makes a take it or leave it offer, then it knows that firm 2 will abate, such that firm 2's abatement will be equal to P over 2, and firm 2's sales, Z, will be, Z is A2 minus 6, P over 2 minus 6. So, firm 1's problem then, given this restriction, so to speak, is to max pi 1, choosing A1, where pi 1 is equal to P times, sorry, it's minus P, isn't it? Times Z, where Z is 6 minus A1. Because this is now a cost. If Z is positive, that's a cost, minus abatement costs, which are 10 plus 2A1 squared. Okay. And let me think here. Okay, so the key thing now is to use the information we've got to say something more about P. So how are we going to do that? We've got this and this. So we know how Z is linked to P but we also don't know how Z is linked to A1. So if we put these together, we get 4 plus P on 2 minus 6, 4 plus Z is 10 minus A1. So that's minus 2, 12. So P over 2 is 12 minus A1. P is 24 minus 2A1. Okay. So we can substitute that in here. So pi 1 is minus 24 minus 2A1, 6 minus A1, blah blah blah. Then if we insert this expression for P and take the first order conditions, what do we end up with? Well, take the first order condition. So if we differentiate this, we get minus 2, don't we? So minus minus 2 is plus 2 times 6 minus A1. If we differentiate this, we get minus 1, minus minus 1 is plus 1, so that's plus 24 minus 2A1 minus 2A1 squared differentiated is minus 4A1 equals 0. Minus 2A1 minus 2A1 minus 4A1, so that's 8A1 is equal to 12 plus 24 is 36. A1 equals 4. P equals 16. A2 equals 8. So the firm is going to make a take it or leave it offer to buy permits. Is that what the question was? Yeah, firm 1 is going to make a take it or leave it offer to buy permits at a price of 16, and it's going to end up buying 2 permits and only having to abate 4 units, and firm 2 will abate 8. And if we calculated the profits, we would find that firm 1 will make more profits than if they'd somehow agreed on an equal bargain. To check that this is the correct solution, we should check against the corner solutions. So you would need to check against firm 2's option not to trade at all. Because that's a corner solution, the first order conditions aren't helping us, so we need to check that separately. Unless we've got this kind of convexity in the problem, which means that we always know we're going to have an internal solution. We don't have that convexity here. So that's important to bear in mind, especially when you're dealing with real world problems. Okay, that's me for now.